So hey guys, welcome back, and today we are going to solve another problem in our graph playlist, and that is 959 region cut by slashes. So this is very interesting problem, and this problems allows you to think how we can think of what problem we could solve from the graph approach. So this is really very unique problem where no node is given, no vertices is given. We have to create our own node. We have to think of it like how we can come up with this approach. So the biggest part in this problem, the biggest challenge in this problem is we have to relate that it will be solvable using graph, right? So let's first try to understand what the question says. So I'm not gonna read out, but let's quickly see that what exactly the question asks. So the question will be given you a grid. The grid will be a one-dimensional array, right? One-dimensional array, and in that array you can see that this is one-dimensional array, and in this one-dimensional array, what you can see is it has two rows or two elements. So this is row 1, and this is row 2, right? And in if I take any element, if I take this element, you can see it has a two character. The first one is a space, and the second one is a forward slash. And in the second row you can see there are also two character. The first one is forward slash and the second one is a space. You can see here, you can see. Okay, so now you can see that it has two rows and two columns. So rows basically means that length of grid, and column means length of grid of let's say any element 0. So this is two rows and two columns. So when you are given a grid, what you have to do is you have to exactly this is represented as so we will make a grid. Okay, we made a grid here, and so this is two rows and two columns, so we have to make two rows and two columns here. And now let's traverse it. So the first is a space, so we don't do anything, and in the first row second column we have a forward slash, and in the second row first column we have again a forward slash here. Okay, and in the second rows and second column there is nothing. So now what we have to do is we have to tell that how many possible region we have here. So the first thing is here and the second thing is here. So these are two regions. So we have to return the how many regions are possible here. So we have to return 2 here, right? Now what exactly can happen? Let's say let's take another problem here. Let's see that this could be in this problem the possible slashes could be a forward slash or a backward slash. And you know that this backward slash, if I represent this as a backward slash, it will be taken as a escape character. So to do that, what we have to do, we can whenever we try to put this in a string, we have to make a two backward slash, so that the single one would be escaped and the second one will be preserved, right? So something like that. So we will have the forward slash here, forward slash, and the backward slash, and the space, right? Space. So there are three possible character in our grid, right? So what happens, let's take our question here. So you can see that there is the backward slash, and that is represented as a two backward slash, right? And let's see like what we can do here. Let's say we are given something like this. Let's say this is grid, and let's say something like this, and let's say this is something like this. We are given this thing, right? We are given this thing. So what does that mean? Two rows and two columns. Here you can see that two rows and two columns. This will be, you know, the length of this thing will be 1, because 1 is ignored by our compiler, and it will be treated as a single backward slash. So we need to make two rows and two columns. Here I made two rows and two columns, and this is like this. This is the first thing is a backward slash, so I made it, and then we have forward slash here, at this point we have forward slash, and here we have a forward slash, and then we have a backward slash. Now could you tell me how many possible reason do we have here? So here we have 4 possible reason, right? We have here 4 possible reasons. So this is our question. So now the biggest problem is how to think of this, like how can we say that this is a graph problem, right? So now let's see that how will be our thinking approach. Let's say this is a single cell. Let's say this is a single cell. Okay, and let's say this is a single cell. This is 1 cross 1, right? This is a 1 cross 1, right? So now what we can do in 1 cross 1, this could be either forward slash, this could be a backward slash, or this could be a space. 3 things, right? So if I take this forward slash, this could be something like this. Okay, and if I take this backward slash, it will be something like this. Okay, actually I'm just slicing it. I'm slicing it actually. And if this is a forward slash, I'm slicing it. Okay, and if there is space, then all the, if I take this, okay, let's say I sliced in forward direction, then in the backward direction, and let's say we didn't slice. So when we didn't slice, we will have one reason. And when we sliced in this direction, let's see that if we sliced in this direction, we will have 2 reasons. The one is this and the one is this, right? And now when I slice in this direction, we will have 2 reasons. One is this and one is this, right? So what we can think of, let's say let me take this one. So we can think that this is a node. We can think of this is a node, and this is a node, and this is also a node. This is also a node. These smaller triangles are a node. Why? Let's see why. Let's say what I did is I sliced in this direction, right? In this direction. So if I connect these two nodes and these two nodes, I can pretty much say that okay, let me erase all these things because it's getting too messy. Okay, it's getting too messy. So let's say I sliced in this direction, and our possible triangle will be, all possible small f triangle will be like this. And one is this and one is this, and let's name 0, 1, 2 and 3, right? And let's say I sliced in forward direction, like I sliced in the forward direction. What will happen is we can connect 0 and 3 and 3 to 0, and we can also connect 1 to 2 and 2 to 1. That means if I connect it, if I take this as a slice, so we can connect 0, 3 and 2 to 1. Why cannot we connect 0 and 1? Because it is sliced, it is separated, so we cannot connect it. So we cannot connect this thing and we cannot connect this thing, so it must be we cannot connect, right? So okay, so if I slice this way, right, what happens if I slice this way? We will get 2 reasons here. The first reason is this one and second reason is this one, and we get 2 reason. Let's say I took another 1 cross 1 again, 1 cross 1, and we try. Now we will, this time we will cross and slice up at this side, and our possible triangles will be these things, right? So this is 0, this is 1, this is 2 and this is 3, and our sliced will be on this way, right? So what we can do, we can connect 0 to 1 and 3 to 2, right? And 0 to 1 and 3 to 2, 1 to 0 and 2 to 3. So we can do these connections, right? We can do these connections. So okay, that's fine. Then how can we think of that? This is a graph, this is DFS. How can we think of, let's how we can think of. Let me do one more thing, right? Let me do one more thing. what happens is, let's say I have a list of nodes, let's say 0 1 2 3. So these are the nodes, what these are the triangles 0 1 and 2 and 3, and these small f triangle I am taking as a node. I will take a visited set here, and I will take an answer, like answer, let's say I will take a reason here, reason initially it will be 0, right? And in visited there would be nothing inside of it. So when we call for 0, we will check is that 0 in our visited set. No, it's not in visited set currently. So what we can do, we will call for 0 and every possibilities that is connected to 0. Listen, when we call for 0, what it will do, it will get appended in our visited, and it will call for every connected nodes to the 0. So when we call for 0, it will appended in the 0, and it will call for its neighbor. Its neighbor is 1, so it will call for 1. Then 1 is again in visited, right? 1 is again in visited, and our reason will be incremented by 1. Now our reason is 1. Now I called for 1. Is that in visited? Yes, it is in visited. We don't do anything. And when we come at 2, we think, is that in visited? No, it's not in visited. So we call for 2 and we call for its neighboring, right? So 2 is connected to 3. 2 will be called first, and then it will call its connected nodes. So 2 is connected to 3. So 3 will be also in visited, and it will increment it by 2. And again when comes through 3, so 3 is already in visited, so we won't do anything. So we got 2 reasons here. So that was the answer. So this was the reason 1 and this was the reason 2. Reason 1 and reason 2. So this is thing, right? So now you understood how our process is going to work for a 1 cross 1 grid. So when I say 1 cross 1 grid, let's imagine that 1 cross 1 is a cell, right? So this is our 1 cross 1. So we understood that what we have to do, like we have to connect nodes, and what we are taking node as, we are taking each and every triangle, every possible small f triangle as a node. So this is 0, this is 1, this is 2, and this is 3. So these are known as nodes. So in the graph problem we found the node, and we also found that these must be connected internally to be a same grid, right? Now let's think that we have 1 cross 1 grid. We understood that how we connect 1 cross 1 grid. Now let's see that in the question it says n cross n grid, right? If you see the question, it is 1 cross 1 grid that is composed by 1 cross 1 squares, right? So this particular thing is our 1 cross 1 square, and since we have n cross n grid, so all these small left grid must be interconnected. So what I'm going to say is, let's say this is 1 cross 1 grid, this is 1 cross 1 grid, this is also 1 cross 1 grid, and this is also 1 cross 1 grid. So there could be also 1 cross 1 grid. So these grid must be connected as well in every 4 directions, because these grid can be increased in 4 directions. So these must be connected in the 4 direction. Okay, fine. Now what happens is, if the 0 is connected upward, what will be the node it will be connected to? It will be connected to 2, right? It will be connected to 2, right? And when it connects to 2, our row will be decreased because it's going upward. And when the node 1 is going to be connected this way, so it will be connected to 3. It will be connected to 3, and it will be connected to 2 here. And when it will be connected to 3, our column is going to be increased, right? Now when we are going to connect it in this way, let's say we are going to connect it in this way, our column will be decreased, and 3 will be connected to 1, and 2 will be connected to 0. If I go downward, our row will be increased. Okay, I hope this is clear. Now one more thing, is that enough? we have connected each and every blocks by four direction, but we forgot one thing. We also need to connect these internal nodes as well, right? Depending on the condition, we need to connect these internal nodes as well. Like we connected this way, this way, this way, and this way, but these internally should be connected as well, right? These internally should be connected as well, depending on the conditions, and outward connection will be also there, right? When most important thing, when we connect internally, you see that our row and column will not be changed because we are doing in the same cell. But when we are going to connect outside, when we are going to connect in for other cells, our row and column going to be changed, right? Okay, now what happens is, now let's see the cases, what we get the cases. So if there is a space, what we are going to do, we are going to call for the four direction, because the grid could be n cross n, and all these grid must be connected, so that's why four direction. And now when we have no slicing, so there is no restriction, we can connect each and every node, vice versa, we can connect each and every node, right? So 0 could be connected, so 0, let me reduce the size. So 0 could be connected to 1, and 1 could be connected to 0, and all these directions need to be connected, right? So 0 would be connected to 1, 1 would be connected to 0, 0, 3, 3, 0, 3, 2, 2, 3, and 2, 1, and 1, 2. So all these four directions must be connected, and the call will be in the same block. That means our row and column will not be changed. And when there is a forward slash, if there is a forward slash, four direction call will be again here, because we need to connect each and every cells here. And if this is our slicing, this is our cutting, so in that case 0 and 3 will be connected, and 3 and 0 will be connected, 2 and 1 will be connected. So we cannot connect 1 and 0 because this is separated, this is cutted, right? So we cannot do that, right? 2 and 1 and 1 2 will be connected, 3 and 0 and 0 3 will be connected. Now if there is a backward cutting, four direction call again, and if this is backward cutting, 0 and 1 will be connected, 3 and 2 will be connected, 2 3 will be connected, 1 0 will be connected. But 3 and 0 cannot be connected, because there is a cut, so it cannot be connected. Hope that it's clear so far. Now what I have done here is I have summarized what I said so far, right? So if 0 is going to be connected with it will connect upward. So what upward will come? 2 will come. So 0 will be connected to 2, and when it connects upward, r minus 1 will be there, right? Row will be going to reduce, column gonna be same because it's in the same column. And when 2 is going to connected, it will be connected with 0 and going downward, so that's why row is +1. And when triangle 1 is going to be connected, it is going to connect it this way, so column will be increased, and it's going to be connected with 3, column is going to increased. And when 3 is going to be connected, it's going to connected with 1, and column going to decrease. So four direction call. Okay, remember, in every case, just think of it, let it be space or let it be forward or backward cutting, four direction call is always common, remember that, always common, right? So no matter what is the case, we will always connect four direction, right? And the four direction call will be according to these rules, right? As I told you, r minus 1 will be connected, r minus will be there, row will be decreased when we go upward, and all these things, so you know that, right? And apart of that, what else we have to connect? We have to also connect internally, right, depending on the conditions, right? When 0 is going to connect to 3 or 0 1 or anything, our row and column is going to be always same. Row and column will never be changed, because this is going to happen in the same cell, right? Okay, now what going to happen is, here, look at this, this is a code written in Python. So for now, what I'm going to do, let's focus on this DFS function, right? Okay, so no matter what is the condition, I'm going to let's say this is 0 1 2 and 3, right? So this is 0, okay, let me think of that. So this is 0 1. Let me zoom it a bit. Okay, hope that now this is clear. Let's say this is 0 1 and 2 and 3. So no matter what is the condition, we always call for the 4 direction. So if there is a 0, it will be connected to if there is a 0 t equal to 0, it is always going to connected with 2, because 2 come if it goes upward, it goes upward, there would be 2 and row minus 1 will be happen. And if t equal to 1, it is going to converted in going to connected with 3, so 3 is there and column will be increased. And for 2 same thing, and for else condition, that means that there would be 3 and the 3 would be connected with 1 and column would be decreased, right? So we did that, we called for the 4 direction, we called for the 4 direction. Now coming to our condition. Suppose if there is a forward slash, let's if there is a forward slash, what we have to do, we called for the 4 direction and we need to call for these particular thing. We need to connect 3 0 and 2 1, right? 3 0 0 3 and 2 1 1 2. We need to connect these two. Let's connect this. Okay, so if there is a forward slash, we need to connect let's say this is 0, this is 1, this is 2 and this is 3. So if there is a forward slash, that means there would be a cut. So which means I need to connect 0 3 3 0 and 1 2 and 2 1. So 0 3 and when 3 comes, then 0 and 2 is connected to 1 and 1 is connected to 2. So okay, that's fine. Now when there is a backward cut, so this will be 0, this will be 1, this will be 2 and this will be 3, and our cut is backward in direction. So what we going to connect? 0 1, we will connect 0 1 1 0 3 2 and 2 3. So we are connecting 0 2 okay, here actually this is here, okay, this is here. Let me move this back here. Okay, and it is this thing. Okay, it is this thing as well. Okay, so 0 1 and 2 3. So if there is a backward here is there backward, so if there is a 0, it's going to be connected with 1, and if there is 1, then it's going to connect with 0. If 2 is there, then connected to 3 and 3. So it is done. So are we done so far, or if there is something remaining? Okay, so we called for this thing, right? We called for this thing, we also called for this function, right? But we forgot to call these thing, right? Here we have to call for every possible connections, right? So we are going to do the same thing here. We are passing every possible connections, and we are not going to change R and C because it's calling within the block. So 0 is going, if there is 0, then it will be connected to 1 and 3. Hope that it makes you some sense, like 0 1 2 3. If there is 0, it will be connected to 1 and 3, and if there is a 1, it will be connected to 0 and 2, and if there is a 0, it will be connected to 3 and 1, something like that. And if there is, so we have done the same thing, right? Now we had made our DFS function. Now what we have to do, if we come here, we made a visited set. Why? Because in our grid, nodes are uniquely identified, because there is single 0, there is single 3 node, there is single 2 node, there is 1. So there is no possible way of retracing the path, and that's why we only had to store nodes only, right? But in this case, you can see that there are multiple same node, like this is also 0 node, here also 0 node, here also 0 node, here also 0 node. So what can we do to identify these nodes uniquely? We can also pass row and column numbers, right? Or in this function, you can see that R and C and T is going to change. You can see that row number, column number, and node value is going to change. So in the visited set, we will also store the same thing. We store the same thing, R, C and T. In visited, we store those things that are changing, right? So we are calling for all the possible grid and for all the possible nodes. And if this is not in visited, if this is not in visited, we will call for that, and we will increment the reason, and we will recursively call that. If that is not in visited, we will call for that and increment the reason and return the reason. This will return me answer, as we did the same thing here. I explained you that increment reason. So I hope that this makes you some sense. Now you can see the Python code, and you can also code in whatever programming language you code in. So hope that is clear, and if you do have any kind of question, please don't forget to comment that, and I will answer you. Thanks for watching this video. Have a nice day.